There's another handout. It's called What's Your Vector, Victor? Which is a joke from a movie from back in the 70s called Airplane. It's hilarious. But we're going to do the most basic introduction to vectors. And so bottom line is we're going to rename some stuff a vector. So traditionally we start with vector v or vector u, whatever. When we write it, we'll put a little vector symbol over it. But when it's typed, it's bold. Okay, so just know that. But basically what it does is we have an initial point and we have a terminal point. And the initial point is where it starts, and the terminal point is where it ends. Okay, so we have initial to terminal. Oop, that says initiate. To terminal. So initial to terminal. So, and what we end up doing with vectors, and if you're going upwards into calculus, you're going to end up utilizing vectors a ton in Cal 3. In fact, that's all you're going to do is use vectors in Cal 3. So what we're going to do is find out what a vector is first. So in this case, I've got an initial point here. And then you'll notice, if you think back in geometry, it looks like a ray where you have an initial point and then there's this arrow going. The difference between a vector and a ray is that a ray will start and then it will point in a direction but never end. A vector has an initial point and a terminal point. So it will start here, it will end here, it has a specific length. Okay, so what this will say is I've got find this mess right here. That is not absolute value. What that says is this is vector u. You can either use a little arrow like that, or a lot of the times we'll do a little hat. Okay. Again, if it was typed, it would be bolded. But this on either side, these double bars, means the magnitude, which is a fancy way of saying how long is it? Okay, what is the distance between the initial point and the terminal? What's the magnitude? So I just really want to know how long this thing is. So if I look at this, and you're going to have to forgive me, I have to count. So I've got 1, 2, 3. So this point right here is 5, 3. Okay, and then this point right here looks to be -2, 1, 2, 3, 4, 5. So -2, -5. Okay, so I'm going to find the magnitude of vector u. So what I want to do first of all is write it in vector form. Okay, so I need to find out the x coordinates first. So I will choose either one, but whichever one you start with, it better be the one that, actually that's a lie, hang on. This is where I stopped. This is the terminal point. So always do terminal minus initial. So -2 minus 5. So terminal minus initial. -2 minus 5 means that my first one, vector u, is going to have the form. This is called component form. So this is it's the little bracket that looks like that. Okay. So -2 minus 5 is -7. And then again, for the vertical component, you want to do -5 minus 3. So -5 minus 3 is -8. So this vector, this is how you write the vector in component form. This tells me how I moved horizontally. So from initial to terminal, I moved left 7. And then from initial to terminal, I moved down 8. Okay, that's what that means. Now, Pythagorean Theorem would tell you all you got to do is square this. So I get 49 plus square this, and I get 64. So what I end up with is going to be, I am too tired for this mess right here. 64 and 50 is, you've got to be kidding me. 134, and that's too many, so it's 133. Okay, so this is x squared plus y squared, but I took a square root. So this is Pythagorean Theorem. So this thing's magnitude, or the distance or the length of it, is 133. Okay, so now we're going to do it again. That had better be right, because I don't even know. So 49 plus 64 is 113. Lord help me. All right. You're like, she teaches math. All right, so it's 113. All right, so now we're going to do it again. So I'm going to look at vector v. Okay, so the way I write this is vector v. You can use a hat, or you can use that little sideways thing. And I'm going to do this in what's called component form. And I am going to find out this thing has an initial point at 6, 0. And again, I'm hoping I'm counting this thing right because it's really fuzzy. And then my terminal point looks to be at, this is negative 4, 5, 6, 7, 8. It looks like negative 1, negative 8. Okay. So how do I write this? Do terminal minus initial, so negative 1 minus 6 is negative 7. Okay. And then negative 8 minus 0 is negative 8. And then it says, what is the magnitude? So the magnitude of u was the square root of 113. Well, the magnitude of v is going to be the exact same thing. So basically what we know is that if they have the same magnitude, which they do, and if they're moving in the same direction, which they are, then they are equivalent. Okay? So vector u does equal vector v. Now the benefit of that is I can pick up these vectors, and if you think about it in terms of an airplane, okay, if this airplane leaves from here and travels this far to the left and this far down, okay, and if this airplane starts here and travels this far to the left and this far down, they have traveled the same flight plan, if you want to think about it that way. Okay, so their flight plan was equivalent. Now, another way that we can do this, and again, you have your thing here, is I can write this as a unit vector, and I can use an I component and a J component. And when you get up into Cal 3, you'll have a third component, which is a K component. And the I and the J simply tell you horizontal and vertical. Okay, so this says sketch your vector as a position vector and then find its magnitude. So this says positive 3. So your I component tells you left or right. Your J component tells you up and down. And if it's positive, you go right. If it's positive, you go up. Okay, so from the initial point, I'm going to go right 3, up 4. Well, that's not it. Well, here's right 3, up 4. So this is your position vector. We call it a position vector because it starts right there at the origin. These are not position vectors. They don't start at the origin. So this is a position vector. And then what is its magnitude? Well, its magnitude is going to be the square root of, again, I'm just doing Pythagorean Theorem. So x squared plus y squared. And so take its square root and you find out that the magnitude of that thing is 5. So the length of this vector is 5. That's it. Okay? And I've got 7 minutes left. All right, so sketch it as a position vector, find its magnitude. So this one says I'm going to go left 7, down 4. So that means I should be in quadrant 3. Well, here's quadrant 3, but it's facing the wrong way. Okay, you're starting from the origin and you're moving left 7, down 4. So it's got to be this one. And then what's the magnitude? The magnitude is the square of this one plus the square of this one, and then take a square root. Okay, so I get 59, I get 55. So the square root of 55. Okay, that is your magnitude. That's how long this thing is. Now, write this in terms of I and J. We've already done this. So I've got a vector V, and I want to write it in terms of I and J. So instead of writing it in component form, which is what I did here, I'm just going to write it as V equals, and then I'll put an I on this and a J on this. So what do? I do terminal minus initial. So terminal is 3, initial is negative 8. So 3 minus negative 8 is 11. And then 2 minus negative 3 is 5. So this is your I component, and he gets a hat. And this is your J component, and he gets a hat. Okay? And that's it, actually. All right, so that is your vector. So this one is the same thing. Terminal minus initial is going to be a negative 5 minus negative 1. So negative 5 plus 1 is negative 4. And then negative 3 minus 2 is negative 5. And so you have negative 4i minus 5j. Okay? So now, this seems complicated. It's not. If u is 7i, and minus 2j. And if v is negative 8i plus 6j, find u minus v. So what is u? U is 7i minus 2j minus, what is v? V is negative 8i plus 6j. And now all you're doing is combining like terms. So this gives me 7i's plus 2j's. That'll be a plus 8i minus 6j. Means when I subtract these two vectors, I get 15i's. Okay? And then 2 minus 6 is minus 4j's. And that's it. Okay? So I want to find, on this one, I want to find if v is this. This is called a scalar. So if I have a coefficient, I'm just going to increase this thing's magnitude by 8. Okay? So if I have 8 times v, there's a negative 4i plus 5j. So I'm just going to make that a negative 32i because I distributed, and that gives me a plus 40j. Okay? So now, what are you going to do to this one? I want to find 2 w's plus 2 v's. So you're going to take 2 times w. You're going to get a negative 2i minus 6j. And then I need 2 v's. So 2 v's is going to be a negative 18i plus 12j. And then add them together. So negative 2 and negative 18 is negative 20i's plus 6j's. And you're done. So here is where we're going to find the magnitude. And unfortunately, I'm going to have a little bit of a second video, but it won't be long. All right, so the first thing I want to do is I want to find w minus u. So if w is a negative I minus 7j minus, what is u? 6i minus 2j. So negative I, remember that's going to distribute out. So I've got a negative I minus 7j minus 6i's plus 2j's. So negative I minus 6i is a negative 7i. And then negative 7j's plus 2j's is minus 5j's. Minus 5j's. And again, because I would explain what all of this means except for coronavirus. So no. All right, so all I need to do is find the magnitude of this resultant vector. So I am going to take the square root of this one squared and the square root plus that one, which is the square root of that one, which is that one squared. So 49 and 25 gives me 50 and 25 is 74, which, because it's one too many. All right, so now we've got a unit vector. So basically what I want to do is change this thing into a vector that has a length of 1. Okay, so here's all I do. I'm going to have 8i's plus 1j. And all you do is divide both of those by its magnitude. So what's the magnitude? The magnitude is 64 plus 1. So the magnitude is 65. So I'm going to have 8 over root 65i plus 1 over root 65j. Now, if you were to make a triangle out of this thing, so I would go this far to the right and I would go up that far. If you were to use Pythagorean Theorem, that would have a magnitude of 1. That's what you've done, is you found a vector that has a magnitude of 1. So now I've got one more to go. All right, so find the vector v in terms of I and j, whose magnitude v and direction angle are given. So this is actually a formula that you have. So I need to take its magnitude times cosine alpha I plus sine alpha j. And that is all we're going to do. So what is this thing's magnitude? This thing's magnitude is 26. Okay? So I've got vector v is 26 times the cosine of 315i plus the sine of 315j. Well, do I know what the cosine of 315 is? I do. It is root 2 over 2. And what is the sine of 315? It is negative root 2 over 2. And then this is multiplied by 26. So this thing reduces to 13 root 2 on I minus 13 root 2 on j, because the 2's and the 26 reduce. And now we don't need a second video because we're done. And now you're ready for your test. Hang on, I can find my mouse. Found it.